Today, we're going to talk about Rust and SQLite. We're going to work on these 6 examples where we're going to learn the basics, then play a little bit with JSON and JSONB, and then finally, we will be looking at concurrency. And SQLite is one of my go-to SQL embedded database. And the reason why is because it's very embeddable friendly, then is relatively light and fast. And last but not least, is very robust and mature, as well as very well maintained. Okay, enough talking, let's start coding. So first, what you do is you go to your cargo and we're going to add our rusqlite. So we can use rusqlite or SQLite. And personally, I like a lot rusqlite. It's very focused and it's very well done. Make sure you use the latest one. And then that is important. So if you do a library, do not add bundle, because usually you add that when you create a binary that use the SQLite. And that will compile the SQLite as part of our binary. So now that we have that, we're following our XP pattern over there. And so we're going to go to our C01 simple, and we're going to do a cargo watch example, the alias C01 simple. And we're in business. Hello world, so far so good. Okay, so the first thing that we're going to do is we're going to create our connection. And for now, we're going to use the memory. And that is simpler when you learn because you can recreate the database every time you run. So that is a nice way. Otherwise, to open a file, it's as simple as doing that. So my DB, and usually the extension will be a DB3. That will work as well. So if we do that, we're going to import that, and that will create the database. So now we have a connection over there. And as we can see, is because we have our cargo watch is actually created the database over there. So we're going to go back to our in-memory because it's more flexible as we're going to recreate the schema all the time. We press save, that will do the thing, and we're going to go there and we're going to remove this file. Okay, so now we have our connection to our SQLite, which could be to a file or in this case, in memory. Now, what we're going to do is we're going to create our schema. So we're going to use the connection and we're going to say execute. So that is when we want to execute a command without getting a result back. And we're going to do the create tables, the person, that is the names of the columns. And then we have the types. So far, so good. And now there's a little thing here that I will recommend to always put in SQLite is a strict mode. And the strict mode here makes sure that you always have the same type in the column. So it will follow these types. And we're going to see that later. If we don't put strict, then we can have mixed types on the same column, which is definitely not something we want. Then the next step is going to be to do an insert. And so here we are doing an insert in the person table, which is what we had. And we just insert the name, which is going to be Jen, and the year of birth, which is going to be 2000. So we're going to press save, and it should compile and no error. But again, we don't print anything. So now we're going to do the select. And for the select, we're going to do that, which is we select the person ID, the name, and the year of birth from person for year of birth greater than a name variable, SQL variable kind of. We do a prepare statement. So that is usually I'll always do that regardless. And then we do a statement. So that will return a statement. Everything has a lifetime of the connection. And then we do the query. And that is a way that in SQLite, in rusqlite, we are passing name parameters. So it's kind of an array of tuples. And then in this case, we say this one here, which is going to be that one. And then the 1900. Press save is going to compile, but it's not going to print anything. So now we're going to do the print. So we're going to do a while on the row next. So that is returning an iterator of rows. And every time we have a row over there, which is again, all the lifetime is to the connection. And we're going to add a row to give the second one, which is a get one, which is going to be that guy. And that will give us a name. And then just for demo here, we're going to see that row implement debug as well. So that's nice. So we're going to press save. And now we should see that the name, Jen, and then we have all of the row here with the types. So that is pretty nice. Now let's see what happens if we are trying, for example, for Jen to put a number, but rather to have a number as a number, we're going to have it as a string. So still 2000, let's put 2020, for example, and we're going to press save, and then it works. Boom. So the strict doesn't mean that the value has to be of the type, of the matching type. It can do some coalescing. But what is not possible now is we cannot have something like that. So that wouldn't work. And that kaboom. Now, if we were going there and remove the strict, press save, now that will work, but now year of birth is text. And that will be terrible in an application because now you will have some rows where the column will be numbers, and then when there's a bug somewhere, it will be text. So that is definitely not what we want. So typically, and there might be exception to that, but you do want to add a strict, which is not super strict. It's not Postgres strict, because again, if you put a string here, it will do some coalescing, but at least it makes sure that there's only one type all the time, and that is the type integer. So that is very nice. Now, one thing I've done as well, and this is because since I work a lot with SQLite, sometimes I want to introspect what there is in SQLite. So I've done a crate, which is that one, and we're going to put it in a dev dependency because it's not for production, but it is basically pretty SQLite. That will allow us now here to have a print table. So again, it's not for production, but it's super useful. We're going to give the connection, and we're going to say print person. Then that's it. Make sure we import it, press save, and then boom, we have a nice print of the tables. So usually I use that, and you can do print rows and print everything. So it's pretty nice, and it will allow us to debug a little bit better. So that is what we're going to use from now on. We're going to keep this in this file and have that as well. Okay, so now what we're going to do is clear this one up, and we're going to create a new file, which is going to be our C02 join, and that is going to be our base file for now. So still our open memory. Now, what we could do is repeat this create schema again and again. But the reason why I like the XP kind of pattern with the examples and making that a lib is that we can actually go to our lib. I'm going to follow my pattern and say this modules, and we're going to say pub mod db utils. And this is going to be a single file for now. It can grow into a multiple file later. I'm going to do that type alias. So that will allow the other modules will be able to use that, the result of the crate, if it was a rare one. Now it's not, it's kind of a little hack here, but at least this guy won't know about it. So this way I can use a crate result and then make the crate result better over time. So that is a little best practice that I have. Now what we're going to do is have a function like that, which is going to be create schema and then our connection. And because we have a join here and we want to show the join, we need two tables. So here's what we're going to create. First one is we're going to create a table, org, if it's not exist, and that will have the ID and the name. Again, that is just to allow us to do the join. Now, what we're going to do as well is, and that obviously that wouldn't work in production, but this is just for experimental, we're going to delete the content, such as every time we run it, we delete it and we start from scratch. Eventually, we might have something here that say, delete true, false, or whatever, but that would be good enough for now. And then after we create our person table, which is this one, which now has the org ID over there. So that will allow us to have the relationship, and then we are also deleting the user over there. So that is a little bit the strategy right now. We're making sure we import that, and that should work nicely. So now that we have that, we can come back to our join over there, and we're going to create our schema. Press save, making sure that we import that, and then we're going to do a CWE C02 join. And that should print nothing, but it shouldn't complain. So far, so good. So now what we're going to do is we're going to go down, and what we want is to insert our data. And so in this case, what we're going to do now is we're going to do an insert into org, the name, the value, and we want to get back the ID. And this is where we can use returning ID. Make sure that you do not use the all way in SQLite to get the last ID set, because that will create a lot of issues if you have concurrencies and so on. So now, since a while back, SQLite has implemented the returning ID, which is the right way. So in this case, what we do is we prepare the statement, we say returning ID, and so now we know that when we're going to do a query row, this is a special call, we're going to give our name, so that is going to be what we put there. That's the way to do it. And this query row, if we go to the definition, it takes a function over there. Yes, so the function f, which has a row. So like that, if there's only one row back, we can process it into whatever we want. And that is what we do. We do a row get, so that will be row, and then we do a row get, and then we get that. And that we get the first one, which is going to be the ID. So that is very important here, to not use the old way of getting IDs. So that this way we have the row ID of this one. And then we're just going to create some persons or people, and that will be Jane, Mike, Paul, and Pierre. They are all going to be born in 2000. And the way here, just to show a little bit how join works, is I'm doing a modulo 2 here, it could be anything, it doesn't matter. And then we either have the org ID equal to that org ID or to none. So this way here, we are just enumerating across these guys, and then we're setting it, the org ID here. So again, when we created the database, if we go back there, we can actually close these files probably, we see that org ID we didn't say was not new. So it's okay to be new. So this is why in this case, I just wanted to make sure we show the example of when we set new to it. Now we save that, should work fine. And then finally, we're going to do our select join. So for clarity, I put the join like that. So we have the select here, we do the person, and then we do the org name as org name, and then we do a person, and then we just do an inner join and a where clause. So far, so good. And then we're going to execute our query. So we're going to prepare the statement, execute it, and that will return the rows, which will be an iterator. And the thing which is important to note here is that these rows, every time we do that, not everything is loaded in memory. So it's as we iterate that it will do whatever is smart to fetch whatever. I don't know what is the buffer. But if you have a query that has a million kind of things, you don't download the million things. So this is why it's important to understand that the rows is connected to the connection over there, because it keeps fetching as we iterate. And then this is where we have our cool print rows of our pretty SQLite, and we're going to go the rows. Again, this is not for production, but it's super nice in this case. Press save, and then boom, we have those two. Because the other one were new. So in this case, we ask a specific org ID, and so everything is working nicely. Okay, so that will conclude our join, and that is pretty cool. Now, let's go and create our third example. And that will be our C3 values for the dynamic values. So we're going to close those ones, don't need them. We're going to clean that. And we're going to do a cargo watch execute, C03 values. So far so good, no print, there's nothing. So we create our connection, memory, we create our schema with our DB utils, create schema, and now we're going to seed our users. So we're going to have Jane, Mike, and Paul and Pierre back. Everybody has no org ID, so I could have omitted it there as well, but I just put it there anyway. And then we have the 2000. In this case, we don't need the org. Okay, and then what we can do is we can actually do a print table. We're going to give our connection, and then table will be person. This way, we have our table here, which is Jen, Mike, Paul, and Pierre. Now, what we want is we want to have kind of a dynamic update query. So we want to have an update, but we want it to be dynamic, meaning that the values won't be fixed like that. Because right now we have been working with those, but what if we wanted something a little bit more flexible where we build the query dynamically in a way? So for example, let's say that we have a list of value for one user, one row of column name and the value. And the value is going to be of the rusqlite value. So this is what we have. We want to update a user with the org ID 123. So obviously it wouldn't work, but right now the F key is not there, so that will be fine. And then we want to update the name as well with new name 111. That is just an example. It's kind of a silly one, but that is to show the kind of data that we have in input. And obviously you can have different structure, but this is just to show. So we're going to first extract the columns, name, and the values, because that is the way that SQL works. SQL works with when you update or insert even, you split the two. So we have a vector of string and a vector of value, and then we're taking our name value list, could have been a hash map, it doesn't matter, into iter and unzip. That is what it does, the unzip, it split it into two guys. Then, once we have that, we want to build our columns for our update, because we want to have a SQL update. So for that, what we're going to do is, we're going to do shadow, we are going to shadow the column, that's fine, and that will be one string, and we're going to iterate through each column, and then we're going to format it, we're going to put it under quote equal question mark, and then the column name. And then we join everything with semicolon. So this is by hand. Sometimes you might use a SQL builder for it or whatever, but I'm just showing here some examples. And then we're going to build our SQL. So our SQL will be something like that, where we're going to say let SQL, and then we have that. So we're going to have update person. And now that these guys are well formatted, SQL friendly, we're going to do the set column like that. And then here's a trick. for the values, what we want is we want to have a vect of din to SQL. So the way it works is we know that we have values over there. So we're going to iterate in our values. So that will be a reference of value, but then we want it as a din of toSQL. That is a way that later the execute is going to expect. So this way we're collecting into a vector of din objects. So that is what we have. Now we're going to build the where clause, and this will be basically our let SQL. So we're going to shadow it, format our SQL of before, which is the beginning, space, where ID equal question mark. That will give us that. So then after we have our let person ID, and that will be a value integer of 1. So here we are cheating a little bit because we know that, when we create, it always starts at 1, 2, 3. So we're taking the 1, otherwise we could have done the returning ID on top. And now the cool thing is because we have the values over there, which is kind of dynamic, we're going to do values, push, and then we do the reference of person ID. And the typing magic is going to work for us. We need to make sure we import this guy, and that would work. Yeah, so here there's some magic. If we were going to pass the things like that, that will have complained because he would have said, I'm expecting this guy, you are giving me this guy. So we have to do that, to do a vector of this. But in this case, he knows what to expect, and so he does the right coalescing. So that's good. So now we're going to execute it with these two commands where we do the connection, execute. So when we execute, we don't get the row back, we get the number of rows that we have updated. Yeah, similar to Postgres and so on. So I'm giving the SQL and I'm giving the values here. And I need to do that because I need to deref and ref and all these kind of things. And then I'm just print the number of rows updated, which would be 1. Now I press save. And boom, what we have is we have our user 1 with org ID 123 and the name, new name 11. That is pretty cool. So this is kind of a long way in a way, but that is the beginning of a SQL builder if you wanted to build one by hand. Now you can use SQL or this kind of SQL builder if you want. I'm not a big fan of ORM, so usually I like to have a smaller layer, kind of a query builder way, but feel free to work the way it works for you. So that was pretty cool, and that shows us how to do the dynamic value query. So now our fourth example is going to be with JSON. So first we're going to go into our crates, into our cargo. I'm going to add CRD.json. We're going to stop this one for now. And then we're going to create our C04 JSON. So we're starting from scratch where we have our connection, memory, and we create our schema. So far so good. Now, if we look at our DB utils, we're going to see that for person, we have a data T and a data B for text and blob. So text will be for our JSON, the normal way, the old way in a way, and we will use data underscore B, the blob, for the JSONB. So for this one, we're going to use data T. So that is going to be our goal. So we're going to do our CWE, C04 JSON. Should compile nicely, print nothing, so far so good. And now we're going to do the first one, and we're going to insert two users, which is going to be Jen and Mike. But now we're going to have this number here, which is going to be our zip code, and it's going to make more sense later. And that will be the IDs of these two users. So this way, we're going to collect them the right way. And then we're going to have our for loop, where we're going to iterate over that data set. And now I'm going to create the statement, which is going to be that, which is going to be insert person. And we're going to have the name, the year of birth, and the data T, which is going to be the string version of that. And we're going to see later. And here we have the same technique as before, where we have this returning ID. So I go back there. So now I can do something like that, where I'm going to do the query row. I'm putting the name. I'm going to say 2000. And I have the data JSON, which is this one. And I'm saying toString. So I want the string version of it. And then I get back the ID. And I'm going to do ID, push, person, ID. So like this, we keep track of everything. So that should work pretty well. And actually, if we do a print table, we're going to give our connection and person. Make sure we import it, press save, and that will give us like that. So we can see that it's just a string at this point. There's some function that we could call over there that will kind of validate that it's a JSON and so on. But so far, since we have the JSON type over there, we're pretty safe on this way. So now what we want is we actually want to use a JSON API of SQLite to add or update properties within the JSON. So that is a goal of the JSON support in a way. It's not only to store string in it, because otherwise we don't need JSON support. So for that, first we're going to get the person1 ID, and then we're going to make this query. So we're updating person and we're setting the data. And here is a trick. SQLite has a whole set of JSON function, a little bit like Postgres. And then we can say, I want a JSON set. So that would set a property. And so we give the column name. So it would be data T, the same one. And then that is the language, which is the same actually as Postgres, I think, which is a $, and then the dot way of getting into your property. And then I put a value over there, and then the homeowner, I put a value over there. And so in this case, I'm going to put the person1 ID, which is this one. Yeah. And so I can do also question mark with the index of where it is. And it starts at 1. Yes, Lua and SQL are very old things, and they like to start index at 1. And then we have this reference number, which is going to be 2. So that would be the address code over there. So everybody would be at the zip code. It doesn't really matter. And then we take true and we put it as a string. But here is, we do not want the homeowner as a string true. We want it as the Boolean JSON true. That is a string, but we're wrapping it with a JSON function to make sure that we get a JSON value true. And now, if we press save, we should see Jen with a zip code of 94222 and homeowner true. That works pretty nicely. So when you look at the SQLite documentation, there's quite a bit of function here with JSON underscore, set, and array, and all these kind of things. So it's pretty complete and it's very well done. Now, one thing where JSON is very powerful as well is to select. So here's how it works. So let's say we're going to comment this one out actually. And now we're going to do this one. So now what we want is we want to select all persons that are in a homeowner true. So the way it works is this way. We select whatever we want to select. We make sure that we select the type here where we have our JSON. And then we can do a where clause. And here's a trick is we do a JSON extract. And they have another kind of notation as well, which is kind of compatible with Postgres. But right now we're going to use a function way. So we can do a JSON extract. Then again, data T. And then we're giving the path. And then here we're going to give a name argument. So that would be a prepare statement again. And the way that we're going to do it is we're going to do the prepare statement query. We're going to say that the homeowner is going to be the reference of true. So here's the trick is when you use JSON extract, the type over there, that has to be the type of SQLite, which is what is happening when we're doing that. That is a Rust type, and the rusqlite is changing it into a SQLite type. That's why it works. Now, if we press save, should work often, we get that, we get only Jen, because only Jen, that is the thing that we updated, has a homeowner true. That is pretty cool. Now, the thing to understand is when we're working with text as JSON, so those are the JSON extract and so on, what is happening is SQLite get all of the text out, parse it, look at the value, and then match it and so on. And the same thing for update and everything. JSON set, it will get the value out, set the value, and get everything back in. With the JSONB, it's much more granular. So there's some big value of using JSONB over the JSON text. And now, obviously, we can have more complex kind of select. So for example, here we're going to say people that do not own a home. So we're going to select everything, for example, from person, and where either the homeowner is new, so hasn't been defined, or the homeowner is 0. And again, here the 0 looks weird, but I wanted to defer the things. In SQLite, there is no type Boolean. So when rusqlite changed true to a SQLite type, is actually changed true to an integer type, which is either 0 or 1 when you have a true type. Now, here in this case, I wanted to show how we can hardcode the value over there, because now we know that it's false, so we can hardcode that for whatever reason. And so in this case, we can say 0. So obviously here, if we would put true, I mean, this doesn't even exist. It will return everything, because even the one that doesn't have the value. So what we want is to have the 0 here. That will do that. And if we do a 1, it will return probably everybody. That is the way it works. So now we have that. Okay, so now that will conclude the text JSON. And now we can go into JSONB. So I copy everything there and it's going to be very similar. So this way we can scan it through very fast. So first we create the database exactly as before. And remember, we have the _t and _b. So now we're going to use obviously the _b. So we have our data and we're going to have our JSONs. So that is a CRD JSON. So the value here is a CRD value, is not a SQLite value. And then we're going to prepare our statement where we have our name and things. And this time we do a data B. Now, in our SQL, the query row, we are going to give the string, but then in the SQL, we're going to make sure that we're wrapping it into a JSONB. So this way, the SQLite can take this text and do its magic to parse it into a binary format. So that is where the magic happens. And then we push the ID exactly as we did before. So we're going to stop this one actually and do a CWE C05 JSONB. And so everything is working nicely. And so for the top here, it's exactly the same, except that now we have this JSONB. Now, when we're going to make the query, here's the thing, the way it's going to work. It's actually very much the same, except that now rather to put a JSON set, you put a JSONB set. Now, the magic here is because the way they store it, the JSON in the binary format, which is obviously super smart, when we do a set, it's not going to parse the whole beast. So they are going to be relatively optimized and they will be able to go directly into those nodes. And that is a big value of JSONB. And again, when we do the JSONB set here, this is the same thing. We have to make sure that if we are using a string in this case, and we wrap it into a JSON, something like that. So that will become a JSON type, which is what we want inside the JSON function. And then if we go down, we can see that now we're going to use another notation to do the same thing that we did before for the select. So in this example, I'm showing different ways of doing it. And I'm using that notation, which is this guy. I think we can put a space over there. And if we press save, hopefully everything works. And that means that this is a colon. And this is a way to address. So rather to have the function that we had on top, which is that we have, I still have it there, JSONB extract. Now we can do as well like that. Now, this conflicts with my best practice of debug print. That is a me problem in a way, but this is pretty nice and I think is the same as Postgres. So that's pretty nice. That's the way to address, still the same. And then there is this kind of difference between when you are using 2 greater than and 1. So when you are using 2 greater than, the types on the right is a database type. So that will be the SQLite type. So for a Boolean, for example, that should be an integer because in SQLite there is no Boolean. And so that would be the integer 0 or 1, for example. But if you use this guy, then the right side needs to be a JSON 1. So that will be thing. So that's why this works. Now the JSONB extract, like the JSON extract, they work with a SQLite primitive. So here we do not give JSON something, we give the SQLite, and for Boolean, the SQLite of a Boolean is integer in SQLite. Okay, so that is our JSONB. Very similar to JSON, but has a lot of performance benefits. So usually that will be my go-to. Okay, so now what we're going to do is we're going to do our 6th chapter. And that will be our C06 Async. And that is how to use SQLite and the connection in Tokyo Async or threading. It's the same thing. It's basically what is send and sync and so on. So for that, we're going to use Tokyo Async. But again, we could have done the same thing with multi-threading. It would have been the same characteristic in many ways. So we're going to put that. We go back to this file. We're going to make it async with Tokyo main. And for that example, we're going to actually save it to a file just for fun. And that will be the underscore. So like this in my git ignore, I don't save it. By default, the underscore is ignored. And then the db3. So press save. We're going to do a cargo watch execute C06 async. And that should create our underscore mydb db3. There were a leftover file over there. Okay, so now that we have that, we're going to have our list of names that we're going to insert. And at the bottom, we're going to have our final print, such as we print the table here, person. And then over there, we're going to do a for name in names. And then we're going to do another loop. So it's going to be a little bit silly here, but we're going to do a for I in 1 until 10, 9, I guess. And that will be the let name. We're going to format it and we're going to take the name dash I. So like that, it will give us a unique name all the time for every run. And then what we want is to do the insert. But we don't want to do the insert within this task, because the whole point is to see how to use a connection in a multi-threaded or multitask, to see what is send and what is sync and so on. So what we want is we're going to do a let. We don't really care about the result. And we're going to have a Tokyo task. And here we're not going to do the blocking or whatever. We're just going to do a spawn and we're going to do an async move. I guess that now we could do an async closure, but this one will be good for now. And here's a trick. The trick is we cannot use that connection there. And that is for good because SQLite support multi-threaded access, but the connection doesn't support multi-threaded. There's a way in SQLite to compile it for it, but it's not recommended, and I don't think it's a good way. And luckily, rusqlite is very good, and they don't compile it this way. But you can create a connection per task. And eventually, you will use a DB pool or something like that, like Deadpool and so on. But right now, we're going to do it by hand to understand how it works and the limitations. And then we might have another video of how to use database pool and so on. But for now, we're going to do a let con. And we're going to have that again. And then this one here to string. That will make it a little bit more flexible for this example. We're obviously going to put the await. And then here, we're just going to do that. So we're going to execute insert person and with our value here, our names that we have there and the value there. So very simple. Press save. Everything should compile nicely. And then we can see that we have all of that, which is a 9 times 2. So 2 users, and then we created clones kind of things. And then in our create database, we are resetting all the time the table. So that's why it's stay at 18. If we were going to go there and we were going to say, I don't want to delete, and press save, 36, 54, and so on. So that's the way it works. Everything works very nicely. So we have two choices. Either we use a database pool connection, which is completely fine, into our thread. And so the database pool connection will do its magic here to do these kind of things. Or, and I think is valid as well, is we have the connection with another DB kind of things that we manage, and it's behind mutex. So that might be good as well. Or if we know that we don't have that many threads and everything, it's completely fine to create one per thread or per task. But the point here is that we couldn't do that. This is not a thing. If we were using connection, which is this one, which is used over there, but even if we were not used over there, press save, obviously we couldn't move it. So then the thing is like, well, perhaps we could do something like that, where we do a let con 2 or clone, and then we do a con clone, but that is not a thing. Yeah, so that is not that doesn't work. So which makes sense, yeah, because you do want to do these kind of things. The pattern is pretty well. That is the way it works. And now we go back down, make sure to re-enable this, and then everything is work nicely. So in the future video, we're going to see how we can use database pool and make our own wrapper with mutex manually. And that really depends on the use case. And that will be it for this video. Hopefully you liked it. Like and subscribe, helps a lot. And by the way, I created something pretty cool in Rust. It's fully open source. You have the binaries, or you can compile it your way. And it does allow you to create agent and to use a procoder to have a very efficient way to do production coding with AI. And you can go there, and there's quite a bit of videos over there to show how to do production coding with AI Pack and AI. Until next one, happy coding.